WLAN communication is a two-way process. When an Omada EAP transmits wireless signals to a client, such as a cell phone, the client transmits signals back to the EAP likewise. RSSI, Receive Signal Strength Indicator, is a parameter that shows the strength of the signal received at the receiver. The WLAN icon we see on the top of our phone shows the RSSI from the EAP. Since the two-way signals are independent, you may experience your cell phone displaying a full WLAN icon, but due to your phone's low transmitting power, the EAP may not receive a strong enough signal. This can lead to poor actual network speed. Here, we'll introduce two concepts. The first is link speed, a variable value representing the theoretical maximum data transfer rate of the wireless link under optimal conditions. It is influenced by factors such as RSSI, network environment, EAP and client WLAN specifications, and an antenna number. The second is the actual speed, which, constrained by WLAN protocols in the wireless environment, typically falls below the link speed. This video will show you how to check the RSSI and the link speed and estimate your actual wireless network speed. Step 1. Connect the Windows laptop to the wireless network. First, manage the EAP with the controller according to the network topology and set a wireless network. For example, set a 5G SSID on the controller with the name EAP660HD. Then connect the laptop to the network. Step 2. Open the Network and Sharing Center. Here, Windows 10 Enterprise LTSC is used as an example. On the laptop, open Settings, then find and click Network and Internet. Next, on the left board, click Wi-Fi. Then go to Network and Sharing Center. Find the SSID that the laptop is connecting to and click Connections. Step 3. Check the link speed. In the pop-up window, find speed and signal quality and record the status of them. Please note that here, speed refers to the link speed, and we can use it to evaluate the actual speed of the wireless network. The icon on the right side of signal quality represents the current signal strength from the EAP, with more green squares representing better signal strength. Now, click Details and record the IPv4 address of the laptop. We will use it in the following step. Step 1. Enable Signal, SNR, RX rate, and TX rate. Log into the management page of the Omada controller. Go to the Clients page, then on the top bar of the Clients list, click the ellipsis icon. In the drop-down list, find Signal, SNR, RX rate, and TX rate. Enable all of them. Step 2. Record Signal, SNR, RX rate, and TX rate. Now the Signal, SNR, and RX-TX rate will be displayed in the Clients list. Find the laptop according to its IP address we recorded in Part 1, and recorded Signal, SNR, RX rate, and TX rate. Please note that Signal refers to the value of RSSI that the EAP received from the client. SNR stands for the client's signal-to-noise ratio. The RX rate refers to the upload link speed of the client, and the TX rate indicates the download link speed of the client. The actual network speed of the client can be estimated by the link speed. In the above steps, we have two link speeds. The TX rate in the controller refers to the download link speed of the client. The RX rate in the controller stands for the upload link speed of the client. We will use the TX rate and RX rate to estimate the actual speed. For clients with an SNR above 37, it can be assumed that the interference in the wireless environment is relatively low, and the actual speed is half of the link speed. For clients with an SNR below 37, calculating the physical data rate, the actual bit transmission speed, is necessary. This process is complex and is not elaborated here. We recommend that you optimize your wireless network first if your device's SNR is below 15, since a network experience will be seriously affected. And for Wi-Fi optimization, please stay tuned for more upcoming how-to videos on our channel. For example, according to the information on the controller, the SNR is 55, and the RX rate of the EAP is 780 megabits per second, so the actual upload speed should be around 390 megabits per second. Likewise, the TX rate of the EAP is 866.7 megabits per second, so the actual download speed should be around 433.35 megabits per second. Now, open the browser of the laptop, visit the speed test URL www.speedtest.net. Click Go on the center of the page and wait for the speed test results. The download speed and the upload speed will be displayed separately. They are the actual speeds of the laptop, and we can compare them with our estimation. You may find that the download speed and upload speed are lower than the estimation value. This value can be affected by many factors. One might be the actual download-upload speed from the ISP. For example, the test result is limited to 93.86 megabits per second and 19.07 megabits per second, since the download and upload speed from the ISP in this test environment is 100 megabits per second and 35 megabits per second. Another may be interference from the wireless environment. If the wireless environment is poor, for instance, with high signal interference, the actual speed will fall below the estimated speed. Finally, there could be other clients occupying the traffic during the speed test. In this case, we suggest disabling the traffic of other clients for the test.